Gzz. Welcome, Padawan learners. Today begins your training in the ways of the Force, and eventually you will learn to bring balance to the universe. I know that you are anxious to become a Master Jedi like myself, but we must start with the basics, one step at a time, and that brings us to today's lesson, working with expressions. We are not talking about facial expressions. We are talking about mathematical expressions such as these. Let's jump right into some important vocabulary. First up is variable. A variable is a number that can change or that is unknown. In math, we often like to use the variable x, but we could use any other letter as well, such as y, z, q, or anything else. A constant, on the other hand, is a number that does not change. It is a known value, such as 5, -2, 2000. Really, it's just any number that you know. Next up is an expression, a math phrase that can have numbers and variables. We have an example of an expression right down here, x plus 7. Notice that this expression has a variable, which is x, and a constant, which is 7. A term is each individual part of an expression. In this case, the terms are x and 7, each component of the whole expression.
Gzz, Mr. Z, tell me what a coefficient is.
All right, easy, Darth, I got you. A coefficient is a number that multiplies a variable. I like to think of it as the number directly next to the variable. In these examples, the coefficient is 3, -2, and 14. Each of these numbers is multiplying to the variable x, or just directly next to the variable.
You think you're so smart. Well, what is the coefficient next to these variables?
Well, I'm glad you brought that up. Actually, when there is no number that is visible next to a variable, we automatically use a 1. So the coefficient of this x would be 1, and the coefficient of this negative x would be -1.
Haha, this magic looks of the dark side of the Force.
Well, it's not magic actually. The reason we use a 1 is because whenever you multiply something by 1, it does not change. For example, 1 times x is x. 1 times x over here, -1 times x is -x. 1 times 5 is 5, 1 times 2 is 2. 1 can always be a multiplier that does not change the value of something. Next up, like terms. Like terms are terms that can be combined because they are of the same type. For example, if Luke had 2 lightsabers and 2 Imperial credits, and Obi-Wan had 1 lightsaber and 5 Imperial credits, how many lightsabers and Imperial credits would there be total? We can take a look right here and say that lightsabers are like terms because those are of the same type. We can just count from there, and we've got 1, 2, plus 1 more over here, 3. So we have a total of 3 lightsabers, lightsabers being the like term. Next up, let's find out how many Imperial credits we have. Luke has 2, Obi-Wan has 5. We can add those together, 2 plus 5, to get 7 total Imperial credits. Again, because the Imperial credits are like terms. We could not combine 2 lightsabers with 5 credits and say 7 lightsabers because they are not alike. They are not of the same type. In a mathematical expression, we could use the same idea by looking for terms of the same type. For this example, we have a 3x and a 2x. These are of the same type because they both have the variable x. We can combine these like terms by doing 3x plus 2x, giving us a total of 5x, which makes sense because if we've got 3x's here, 2x's here, we have a total of 5x's. Next, we have our constant terms that are alike, the 4 and the 1. Each of these terms do not have a variable. We can do 4 plus 1 to get 5. This simplified, broken down expression would be 5x plus 5. Let's do one more example. Evaluate the expression 4x minus 3 plus x plus 5. First, we need to find our like terms. Of the type with a variable x, we have 4x and x. Keep in mind that this x has a 1 in front as a coefficient. So now we can take our coefficients of 4 and 1 to do 4x plus 1x, giving us a total of 5x. Now let's look at our constant terms. The like terms here are negative 3, taking that negative sign in front, and 5. If we do negative 3 plus 5, that's going to give us a total of 2 for our constant terms. So our final answer is going to be 5x plus 2. All right, Padawan learners, one last thing for the day. Hey, do you want to be a Jedi or not? That's what I thought. The word distribute means to multiply each term in a group. These parentheses right here are like a bag of items, and in our bag of items we have 2 x's and a 3. This number on the outside is the number of bags that we have. We have 4 of these bags. So to find out what we've got in total, what we do is we distribute this 4 across to each term. Each bag has 2 x's and we have 4 bags. So total we have 4 times 2 x's, which is 8x. We can also have this 3 in the bag, and we have 4 bags, so we have 4 of those 3's. 4 times 3 is a positive 12. That gives us a total of 8 x's and 12. Again, we're taking this 4 and distributing it, multiplying it. 4 times 2x is 8x. 4 times 3 is 12. One last example. Negative 2 times parentheses x minus 5. Let's distribute out that negative 2 to this first term. X, which remember has that automatic 1. Negative 2 times 1x is negative 2x. We can also distribute that negative 2 to this negative 5. We have to keep this minus sign with it. So negative 2 times negative 5 is going to be a positive 10, because a negative times a negative is a positive. That leaves us with negative 2x plus 10. Excellent job today, my Padawan learners. I'm going to leave you with this last bit of wisdom. Steps to simplifying. Start with distributing, and then, if necessary, combine your like terms. I could see the force is growing stronger in you already. I will see you at our next training session.